Welcome to 20 Minutes with Leon, and every week, our special guest. Brought to you by Bio360 Expo, this is the podcast that shines a light on the movers and shakers of the bio-transition and their vision to lead us to a vibrant, sustainable, circular bio world, one where life goes on. So, Célia, good afternoon.
Good afternoon.
And welcome to 20 Minutes with Leon. Célia Sapart, you are the Scientific Director of CO² Value Europe. And if I'm right in saying climate change has been, how can I say it, a preoccupation, but also combating it, an occupation of yours now for quite some time. Can you tell us how that all began, please?
It all began by a passion for the ocean, for nature when I was quite young. So I left my Swiss mountains to go to study ocean sciences when I was 19 years old. And I did a lot of internships, and I discovered a world of research. And by opportunities, I became a climate scientist. I was working mainly on the relations between human activities and greenhouse gas emissions. I studied also the climate of the past. And I did research for 13 years. I also went a lot in the field, and I decided, seeing what is happening in the field, how fast things are moving with climate change, to make a big change in my career 3 years ago. And I decided to engage the front line of the climate actions in joining CO² Value Europe.
And I'm sure those formative years in the field give you a particular insight into nature and the extent of the problem that we have with CO2, having witnessed its impact firsthand more than the rest of us. And when we say this word CO2, our first thought is immediately to think about the huge volumes of CO2 emissions that we as a species are responsible for. And so the simple question is, Célia, how can we reduce these CO2 emissions?
Many different means. There are many different types of solutions depending on the solutions, but we need to really have a systemic view, a systemic approach towards solutions. The first thing is that we need to reduce the use of energy and the reuse of raw materials. So we need to increase energy efficiency, to increase efficiency in terms of the use of materials. So we need to think not only about efficiency, but also about sobriety. So which services, which goods do we really need? Because we are living in a closed system, in the Earth is a closed system, so we're not going to have access to non-renewable material and energy for a long time. We need to develop low carbon and renewable energy systems. We also need to electrify everything that can be electrified, but also we need to create low carbon fuels because there are some applications that cannot be electrified. And we need to think circular. Circular, it means that we need to use the waste, and one type of waste are the CO2 emissions and all the pollutants that we are emitting. So gaseous waste are also part of the circularity. And it's very important, considering the main cause of climate change. So the fact that we are using fossil carbon, we are extracting fossil carbon, and it's this fossil carbon that goes to the atmosphere that is the main cause of climate change. And we need to stop that, and the only way to stop it is to create carbon circularity, so to use the carbon we have at the surface of the Earth to as a feedstock for the different applications as we are using it now. So carbon from biomass, for example, or carbon as a CO2, or carbon from recycling. And the last things we can do with all the emissions that we cannot avoid, it's to capture the carbon, to capture the CO2 directly at the flue gas when we have unavoidable emissions, or to take it from the atmosphere and to store it, for example, in products or in the ground, in the underground.
So, Célia, I'm going to come back again to something you said just before. It was 3 years ago that you made the conscious decision to join the front line of combating climate change, and so you came to CO² Value Europe. And can you tell us then what it was about CO² Value Europe that made you decide that this was the place for you to roll up your sleeves and get involved in taking action?
CO² Value Europe, it's really an organization that works on the cause of climate change. So it's not just about capturing CO2 emissions or capturing CO2 from the air and do something out of it. It's also to find solutions to defossilize our economy, so to move away from fossil fuel. So this is really working on the cause and not only on the symptoms. As decarbonization is working on the symptoms, defossilization is working on the cause.
Yeah, there's an expression that comes to mind, working at the coal face, which which is all about diligence and applying oneself to a cause. But here we're working at the carbon face, the renewable carbon
Exactly.
face, right? So language can evolve also as our approach to how we inhabit this planet evolves. So should our language. So
Definitely.
out with
And
the coal face, in with the renewable carbon face.
Exactly. And I think the language did evolve a lot over the last few years on this subject.
Yeah, it's true. It's true, and that's an important part of being able to communicate to people and people being able to understand what it is we need to be doing. Okay, when we're talking about language, there's quite a lot of terminology involved here around this subject of CO2, CCU, CCS. Could you maybe deconstruct a little bit of that for us and tell us what the different terminology is and what it stands for?
Yeah. So if we base the terminology on what is defined by the IPCC, so the Intergovernmental Panel on Climate Change, carbon capture and utilization, it's a fact to capture CO2 or from the air or from flue gases, and then to convert the CO2 into useful products such as chemicals, renewable fuels, or different type of materials. While CCS, carbon capture and storage, it's a fact to capture CO2 at the stack of a specific industry and to store the CO2 in the underground. And then we have other kind of terminologies that are related to bioenergy. And BECU, it's the fact to capture the CO2 from the bioenergy and to convert it into a product or to store it even in products, for example, via mineralization. And we have BECS, which is the fact of capturing the CO2 from bioenergy, but to store it underground. So we really have very specific terms for specific things, and very often it's mixed, while in fact CCU, so carbon capture and utilization, it's a circular process, while carbon capture and storage, it's really the continuation of a linear process.
Okay, that I think is clear, but just so we really get it, CCU, BECU, CCS, BECS. Why the BE? What's the difference between the without the BE and with the BE? Could you just repeat
with the
that,
BE,
please?
it's really that with the BE, it's really the fact that we are using the CO2 that is coming from bioenergy. Because when we burn biomass to create energy or anything else, we have CO2 emissions. And the idea that we want to do something with these CO2 emissions, of course, to decrease the impact on climate change. So we capture the CO2 and we can use it in a product when we do BEC CCU. Or we capture the CO2 and we can store it underground when we do BEC CCS.
Right. So with the BECS, in fact, it's atmospheric carbon dioxide that is initially taken by the photosynthesis of the plants and then re-released and recaptured. But if it's not BECU, then that carbon is maybe coming from somewhere else in the first place.
Yeah. So when it's BECU, it means that we have biogenic carbon that indeed that is originally coming from the atmosphere, that has been taken up by biomass and that is burnt, and then it's captured to do something out of it. Then the impact, of course, is very different, because if you take the biogenic CO2 and you capture it, you really remove it from the air. While if you take just CO2 from flue gas that is coming from fossil sources, for example, you are not removing CO2 from the air, you are just reducing emissions.
I see. Okay, so that's the key difference. And then, I mean, there are other terms that it would be maybe interesting to have you explain to us. There's things like CO2 reduction, CO2 avoidance, carbon removal, offsetting. How do these all fit together, please, in this scenario?
Yeah, these terms are very often mixed up. So we have the net emission reduction. So it's a reduction of the amount of CO2 or other greenhouse gases that are emitted to the atmosphere for a specific service or a specific sector. And we have the avoidance, so emission avoidance, and this means that we avoid the use of an emission-producing service, and we really avoid it entirely so that we do not have CO2 emissions anymore. And we have the CO2 removal that we also call CDR, and these are anthropogenic activities that are removing CO2 from the air and durably storing it away from the atmosphere, so or in products or underground. And when we have the carbon offsetting, and this is a compensation. So it means that we continue emitting. That should be for unavoided emissions, so emissions that we can absolutely not prevent, for example, for the production of cement, and that we store part of this CO2 in the ground or in a product. But we cannot do, for example, avoidance, for example, avoiding to cut tree and continuing the emissions. This is not compensation.
On carbon removal specifically then, and even in the scenario whereby tomorrow we have drastically reduced our CO2 emissions and established a near balance between the CO2 we emit and the CO2 we capture and utilize as a feedstock to produce what we need in a circular fashion, there will still be an excess of atmospheric CO2 that will still need to be removed, and for good, because if we don't do that, then just by remaining there, it will in itself continue to push up temperatures and continue to exacerbate climate change. So we do also need to capture and remove this buildup of excess CO2. And just to be clear, there is a whole raft of terms that apply to doing this, but that mean the same thing, such as carbon removal or carbon capture and storage, CCS in other words, or carbon sequestration or carbon drawdown.
Exactly. So to reach climate objectives, we have already emitted too much greenhouse gases in our atmosphere. So we first need to drastically reduce the emissions, but we also need to create solutions to remove the CO2 from the atmosphere. And of course, we can remove it in planting different type of vegetations, but we can also, and we will have to also remove it directly, technologically, in developing, for example, direct air capture solutions.
Right. And I believe also biochar is a significant one of the IPCC 6 negative emission technologies that have been identified for carbon drawdown.
Yeah, of course. That's another pathway. So, or we can take directly the CO2 from the air, or we take it via the biomass with biochar and with a different type of biomass applications.
And then we lock it away. Exactly. Okay.
So coming down to earth then, Célia, if you'll excuse the pun, how does CCU work on the ground? In other words, how does it work in practice?
So they have many different kind of technologies, but we can divide it in two types. One type is the mineralization of the CO2. So we take CO2 and, for example, construction wastes that are very rich in minerals and water. And with that, we can mineralize the CO2 into different type of rocks. So it's the same way as we made all the limestone, different type of hills and mountains we have around us. But this took a very long time on the geologic time scale to be constructed. We can today do the same thing in a laboratorium in controlling different factors only in a few minutes. So we can construct rocks out of CO2. And what is interesting is first that we can permanently lock in this CO2 in construction materials, but we can also create these aggregates where CO2 is locked in and replace part of the cement, for example, in concrete mix. Knowing that cement is a very carbon intensive product, this is interesting to decrease the carbon footprint of the product. And we have other type of technologies, which are called power to X. So it's a fact of using renewable energy to electrolyze the water to create hydrogen, so green or renewable hydrogen, and make this hydrogen react with the CO2 to create a whole set of hydrocarbons. And with this type of technologies, we can really create more or less all the hydrocarbons we have around us and in the industry, so in type of renewable fuels, chemical building blocks, etc. So this is also a very interesting subject. The big difference is that mineralization is an exothermic reaction, so it means it does not require energy, it brings energy, while power to X, it uses quite a lot of energy. So we need to have a lot of renewable energy if we want to be able to do that and upscale it.
So you talked about some of the carbon capture process technologies, but what about from the application or sectoral perspective? What are the sectors where CCU can be applied today, which will enable significant CO2 avoidance, as well as maybe emission reductions and even some cases CO2 removal?
I think we cannot identify one sector that really drives the CCU sector, because the CCU, it cannot really be defined as a sector. It's more that CCU plays a role in many different sectors. For example, in the construction sectors, because it allows to have renewable and low carbon fuels. It also allows to replace materials. For example, we can have CO2 that reacts with industrial waste and we can make new kind of materials with that. So the climate problem is really a big emergency. And one very interesting thing for the energy sector is that renewable fuels, so fuels made out of CO2 and hydrogen coming from renewable electricity, they allow to store renewable electricity, but they also allow this electricity to reach sectors that cannot use electricity directly, so that they will use it under the form of renewable fuels. So this is very interesting. And also for the chemical sector, it's very interesting because right now the chemical sector is very much based on petrochemicals, so using fossil carbon as a feedstock. And we need to change that. We need to move away from fossil carbon. This is also very clear. We know today that we need to move away from fossil carbon to reach climate objectives. So or they can use biomass, or they can use CO2 to defossilize their processes. And CO2 allows to create more or less all the chemical building blocks that are required for the chemical sector.
Those are some heavily emitting sectors that you mentioned there. So it makes complete sense, of course, that we focus on those as a starting point to bring down emissions.
So CCU, how can we actually assess the impact of CCU, and how can we be sure that any assessments that we have of its impact are in fact accurate? What's the science on that?
In fact, it's very difficult to assess the impact of CCU as a whole, as a concept, because CCU, it's a huge set of technologies, a huge possible set of applications. So we cannot assess exactly the impact of CCU to mitigate climate change, because the granularity is huge, and it's one of the reasons why until now it was not in the IPCC report, because the climate scenario models were not allowed to reproduce the granularity of this CCU. But what we can do to assess the impact of each type of CCU technologies in a specific type of context and applications, it's to use life cycle assessment and also techno-economic assessment when we want to evaluate the commercial competitiveness of such technology and context. And we really need to be very transparent and very systemic also in this evaluation. So we really need to evaluate the full life cycle. So we need to start upstream all the way downstream to the end of life of the product that is created. And it's only in doing that we can ensure that what we are doing will really have a positive impact to mitigate climate change. And what we need is also an harmonized way to assess the impact of CCU. And there is a lot of work that is being done, notably by the Global CO2 Initiative in the US. It's our cousin association. Mm-hmm. And they are really working very hard on that. And in Europe, a lot of work is done as well. So it's really the idea to assess the whole set. And when sometimes CCU is discussed as a solution that is not really playing a role on climate change, it's because the way to assess it's a linear way. It's, for example, sometimes assessed the same way as the CCS, so as a pure decarbonization solution, but it's not the way to assess it, because the main goal of CCU is not to decarbonize, it's to reduce emissions, but mainly to move away from fossil fuels, so to create substitute to fossil carbon, and this has to be taken into account in the evaluation.
So we understand that LCAs can produce varying results in terms of the length of time the carbon is taken out of circulation. And can you say a little more about that, please, and what the variables are?
Yeah, in fact, there are two types of CCU technologies. The one that lock in the CCU definitely, so that's the mineralization, so the fact of using CO2 plus urban waste or construction waste to create carbonates that will create aggregates, etc.
Right.
There, the CO2 is really bound in the rock. It has become a rock. So the only way to get it out of the rock, it's really to burn it at 1,400 degrees Celsius or something like this. So even if you make a building with such bricks that are made out of CO2 concrete, I mean, it's very unlikely that you will heat up so much these bricks at some point to release the CO2. So there, the question is not so much when it will get out. What is more complicated is when you want to assess the role of CO2-based fuels, so these renewable fuels, because it will be re-emitted in the atmosphere. But the idea is to think about what will happen next. Are we going to create a closed loop and capture again the CO2 and put it back in the loop to create new fuels? Or is the CO2 going to stay in the atmosphere? And even if it's going to stay in the atmosphere, if we take CO2 from one industry, we use it, and then, so it means it's not emitted, and then we use it to make a renewable fuel that is used afterwards by a plane, it means we will have one molecule of CO2 in place of two that will be emitted. So it's still a reduction in emissions. Okay. And to make sure that the impact is good, for example, for sure we need to make sure that we do not produce CO2 in the process of converting the first molecule of CO2 into fuels. So it means that we need to use. It means that we need to use low carbon solutions, low carbon energy.
Right, of course. And does that imply a certain level of cascading within the CCU process?
I'm not sure I'm not sure I understand what you mean by cascading.
Well, in that a material that has been produced with an element of CO2 that's been captured from the atmosphere, rather than it can then, when its life cycle is concluded, it can then be retaken by some other process and the CCU element carried on without having any releasing. It can be the idea of cascading as a waterfall. So
yeah, exactly. I see what you mean. So it's the idea is really to make a closed loop, so to really keep the CO2 in this loop, so it's going to go from one process to the other, and the CO2 molecule stays the same at the end. And right now, the big emergency is to drastically decrease our emissions. So we will use the CO2 mainly from flue gases. But with time, in the coming few decades, the idea, hopefully, that we won't have so much emissions anymore, so that a big part of the CO2, especially for the chemical industry, will be coming from the atmosphere or from biogenic sources.
Right. Okay. And then we are back to the principle of circular economy in practice. Okay. Yeah. So we've covered a lot of ground on the question of CCU.
Maybe I can explain. I can just summarize shortly what matters what are the parameters that we need to take into account when we do the life cycle assessment very shortly, because I think it's very important to understand the key elements that matters when we do life cycle assessments. It's a source of carbon, so we need to know if it's coming directly from the air, if it's biogenic coming from the biomass, or it's fossil carbon that has been burnt and that has reached the flue gas or the atmosphere. We need to think about the energy requirements. So we need, of course, to have low carbon energy sources in the conversion and in the capture process for the CO2. We need to think about the type of technologies. Many technologies are today already ready to be commercialized. Some other are still in the lab, and they are not as efficient. I mean, there are big differences. We need to think about the type of product we are creating and also the duration of the storage in the product. And we need also to make sure that we are indeed replacing fossil carbon and that we are not adding. If we just continue to create fossil fuel and we add renewable fuels, it will not have any impact on climate change. We also need to have a good public understanding, so to increase public perception and acceptance related to CCU, and this is the same for all type of technologies. That will ensure also a good market penetration of the different CCU products we can create. And we also need to think very well about where do we set the CCU projects, because you cannot just do CCU everywhere. You need to have renewable electricity, access to water. You need to have the right industry, some emitters, some refineries, etc. for the products. So you need to think about creating industrial symbiosis, and this is a way to really increase the impact when we think about CCU technologies. And harbors are the good places to do that, because they usually have everything you need for developing CCU projects.
Yes, and if we look around the coastlines of Europe, and I know less about further afield, but the coastline of Europe, we see a lot of really large-scale projects starting up, which involves this integrated approach between all the different elements. So that's encouraging.
You mentioned public awareness, Celia, and that makes me think of a parallel world in terms of renewable energy's road from its infancy to becoming a mainstream player and household name. And where today, along its own path, is CCU in this arena of creating public awareness and acceptance, the public being potentially a major demand driver when it comes to making purchasing choices, for example?
So in terms of social acceptance, in fact, we are not very far for CCU because it's relatively an emerging type of technologies. So people do not know very much about it. They often mix it with CCS, which will not be the case because it's not at all the same. So sometimes it herits a bit the negative feelings of people about CCS. That's why we say we should really be clear on the fact that CCU is really a circular approach. So it's something very different. What we see is that if we explain to people really what CCU is, they will usually have a better perception than on CCS, for example. But for example, when you speak about products, you have, for example, mattresses that are made out of CO2 in place of carbon fuels, of oil. And it can be surprising for scientists to hear that, but some people are afraid of sleeping on a mattress made out of CO2 because they think it's toxic. So they prefer to sleep on a mattress made of oil, which is strange. But that we see that the perception is sometimes based on real misunderstanding, because CO2 is not at all toxic for the health. And when it's bound in your product, it's definitely not toxic. So we really need to be very transparent and be very honest also on what CCU can do and cannot do to increase the social and the public acceptance on these technologies, and to be really honest and tell people why it's good to buy a CCU product and what role they can play in mitigating climate change in doing so.
Thanks, Célia. We've covered a lot of ground today, and I hope our listeners will have advanced their knowledge and understanding of CCU and what can seem like a complex subject at times, but once you deconstruct it into its components and then rethread it together again, it does make for a very coherent whole, and CCU is a crucial tool in our armory to combat climate change. So, if I can put it like that. So thank you once again, Célia, for being our guest on 20 Minutes with Leon today. Thank you.
And we're looking forward to seeing you in Nantes in February. You will be there as well as other members of your team. And this will be a discussion that we will continue on the 8th and 9th.
Yeah, thank you very much, Paul, for the opportunity. And I will be very happy to continue the discussion during the Bio 360 week.
Perfect. Okay. Thank you, Célia. Thank you very much. Bye-bye now.
You're welcome. Bye-bye.